And so first thing we need to do is just select on this little bar at the top which PQube we have. And this one we have a PQube 3. PQube ID, this is usually, it might be the name of a machine, a motor, a pump, a process, but we could say this is pump, motor, or location, Dave's house, out, SPW, storage, influent. Then typical time zone. Everything else you can leave as default. Voltage definition. So we're going to do a three-phase circuit. So this on this screen, it's associating L1, L2, L3 with I1, I2, I3. And our load name is mains. AC voltage. The PQube is set up, and so it knows the typical voltages around the world, 100, 120, 277, 4160. And it will at startup try to identify what it's connected to. But my recommendation is you actually set what it's configured, what it is connected to. So we're going to say that your house is the simplest of connections. It's a delta. But let's just do Y, make it more complicated. And on a Y, your house is fed with a 480 circuit, right? And if you have a 480 circuit, your line to neutral voltage is 277, or 480 divided by the square root of 3. Frequency, we're going to be in the United States, so it's going to be 60 hertz. You can leave these as auto or turn them on. Auto should be fine. So in your house, you can drop 480 directly onto a PQube, and in most cases we do.
So setting the potential transformer, the PT ratio, that's, you know, for example, if we're now doing a medium voltage circuit where it's 1247, 4160, and so we would do that ratio of, you know, 12470 in and 120 out, so whatever that ratio is.
All right, leave all this basically the same. Phase rotation here on the West Coast is counterclockwise. It varies, so you should know which phase rotation you're in, but let's leave it all as default. Voltage triggering. I recommend for the first time you set up a PQube, you actually turn all these off. Why? Well, if you've got your voltage ratio wrong or you've an incorrect wiring, you'll get lots of triggers when you power up the PQube, and you may be inundated with emails in advance, and the PQube is busy writing files, and so it appears to act slow. So my recommendation is have all the events switched off at the beginning, and then record trends for a few days, and then come back and set these values based upon the trend values. It's typical for a utility to guarantee you voltage at plus minus 10%, and that's what these are all set up as by default. And what you can do here is on your CT for I123 is you can pick the part number. The one I have here is an SCN2. Oh, we just don't have those. Oh, they're right there. This one. And that's it. My ratio is configured for this CT. There are occasions where you have a Rogowski coil. If you do, you must change this to flexible and then check your flexible CT.
So what happens if if when installing the meter, someone already has their own existing CTs with a 5 amp secondary?
So what you'd do is you'd have one of these, which is a 5 amp CT. And it'll be 5 amp to 0.333 volts, right? So you get their ratio, which may be a 2000 to 5, right?
Right.
Yes, Mark. So what you do now is, because you have a 5 amp CT around their secondary, you make this. You guess? You're going to guess the number? Yes. So it's now a 2000 to 333. again, leave everything else the same. Current triggering, by default, it's all off. And I recommend that you leave it off until we do a trend. And then we can come back and set these values. And that, my friend, is it. You are good to go.